what we have is a situation where we want to use the law of cosines in order to figure out different things regarding a situation, okay? So here, any of you played golf?
I dabble.
A little bit? Okay. I went to the driving range last fall, and that was the first time I had even done that since the day before my wedding, which we're going to have our 12th anniversary this summer, so it's been a while. My clubs literally have rust on them. But golf can be fun. This would be about, that would be a good shot for me. All right. So here we have this golfer, and here's the tee. That's where you hit off from, for those of you not familiar with golf. Here's the tee. That's where you start. And he hits the ball 220 meters. Okay. So this is his first hit with the golf ball, and it lands over here. It's gone 220 meters. Okay. Then he played a 165 meter 6-iron to the green. Okay, so he used a different club and he hit it to the green. Okay, and that was 165 meters. Now, if he had shot it straight, then he only would have had to hit the ball a total of 340 meters. Okay, so he ended up making the hole a lot longer than it needed to be. Okay, because he didn't shoot straight on his first shot. All right, so it says determine the angle the golfer was offline with his tee shot. All right, so what angle are we looking for here?
T.
Yeah, T. He was supposed to shoot this direction. His angle was off by that much, whatever that angle is. Okay? Does that make sense?
Yeah.
Okay? Alright, so, and by the way, if we run into a problem like this, and some of you are really unfamiliar with golf or the language is a problem because it's a different context than you're used to dealing with, just ask, okay? But here's the thing. Now we're trying to find angle T, okay? So what pattern of information are we given here?
Side, side, side.
We're given side, 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 so we're going to use the law of cosines. All right? We're using the law of cosines. Now, with the law of cosines, remember we had some side over here that's squared, and the angle that we're looking for is what we're going to take the cosine of.
So if you go left, you go to the side, right?
All right, good. The side that goes over here has to be the side that is across from the angle you're looking for. So here, across from angle T is the 165 meter side. Okay? The rest of this, we then fill in with the other two sides. 220 squared plus 340 squared minus 2 times 220 times 340 times the cosine of t. Okay? So just be careful that you're setting this up properly. Otherwise, you'll find the wrong angle. It'll be an angle in the triangle, it just won't be the one you're looking for. So now that we have it set up, try solving that on your own. Take it the rest of the way.
no inverse cosine.
What?
Yeah, there's no inverse
Go to
cosine.
the second thing in the top left.
Oh my god, there he is. Got it. Nice. What would I do with that?
I don't know.
Probably die in the hole, thank you.
Probably.
Alright, so if we evaluate some stuff, we start solving for cosine, we should get to this point. Alright? Remember, do not subtract.
I did have an accident.
Okay? Good, you caught yourself though, right? So.
Yeah, I kinda tripped.
Alright, so don't subtract. We want to now divide both sides by that negative 149,600, and we get the cosine of angle T to equal 0.91427, and so on. Okay? So now we've got what that we're going to do.
Inverse cosine.
Good, inverse cosine. And we get angle T to equal what?
23.90.
Okay, yeah, if you round to 2 decimal places, it's 23.897, so it'd just be 23.90 or 23.9 degrees. Okay? If you didn't get that and all of the rest of your work looks right, check to make sure you're in degrees. Okay. Anyone have any questions? No? All right. Now let's tackle one that has a couple of different parts here. Okay? And this will actually introduce us to another way of writing bearings. Remember we looked at bearings that were like north 50 degrees west or something like that? Sometimes you'll be given bearings where it's just an angle. Okay? So we're going to look at how to find that. All right? But it says hikers Ritva and Esko leave point P at the same time. Ritva walks 4 kilometers on a bearing of 40 degrees. Now notice, here's point P. We're walking 4 kilometers. It says a bearing of 40 degrees. Anytime they just say 40 degrees, they're measuring like you would see on a compass. If you've ever looked at a compass, due north is 0, and then it rotates clockwise 360 degrees. Okay? So a bearing of 40 degrees is from due north 40 degrees clockwise. Okay?
So they would say 320 if it was the other way, kind of?
Well, 320 degrees would be
Yeah, like
over here. Yeah, yeah. Then it says that Ritva walked 6 kilometers on a bearing of 155 degrees. So here he changes directions. I don't know. Your guess is as good as mine. All right, he walks 6 kilometers here, and a bearing of 155 degrees. Here's due north again, so it's 155 degrees clockwise. Okay? So that's how we got that diagram.
How do you find the angle there?
What?
How do you find an angle?
Well, we'll get to that. We'll get to that. Now, Esko is either a little less adventurous or a little brighter, because Esko decides just to walk straight to where the campsite is. Okay? Or maybe he's more adventurous and there's a mountain he had to go over or something. Okay? But he goes straight from here to the campsite. Alright? So that's Esko. So the first of all, the question is how far does S go hike? In other words, what's this distance here in a straight line? Okay, don't say 10. All right, in fact, we know our answer has to be less than 10, right? Okay, so the question Matthew just asked is, how are we going to get an angle that's in this triangle? And this is where our geometry comes in handy. All right, north, south. What?
Isn't angle N like to the left of that line 40 degrees?
Okay, to the left of this purple is 40 degrees because north-south is parallel to north-south, so this is congruent to this. That's correct.
Isn't that some theorem?
Alternate interior angles,
Yeah,
yes.
yeah.
We have parallel lines cut by a transversal, alternate interior angles are congruent.
And the
Okay?
other angle's 35.
Okay,
I mean 25.
how do you know it's 25?
180 is minus 1.
Very good. From north to south would be 180 degrees. Since that's 155, this right here has to be 180 minus 155. Okay? So now we know that this whole angle is 65 degrees. Okay?
Easy enough.
And that's huge because without figuring that out, we can't do anything with this problem. All right. So, how are we going to figure out x now?
Just use law of cosines.
Law of cosines. Good. We have side angle side. Use your law of cosines. Good. All right. So we've got x that we're solving for, so we're putting it over here. Let's get down to where our screen isn't erasing everything. Okay. X squared equals, we have 4 squared plus 6 squared minus 2 times 4 times 6 times the cosine of 65. Okay, again, don't be afraid to do some of this in your head. X squared is 16 plus 36 minus 48 cosine of 65. Okay. So what does x squared equal?
31.71.
And that means x equals,
5.63. Plus or minus, but plus.
okay, good, 5.63, and this is all in kilometers. Okay? So this distance here, 5.63 kilometers. Does everyone understand how we've gotten that?
Interesting.
Okay. Now, the follow-up questions here are kind of interesting. First of all, in which direction does S go hike? All right, well here, we're looking for this angle. If we're talking about the direction, all of our other directions were given as bearings. Okay? Now, in order to figure out that angle, obviously we need to figure out the angle that's in the triangle, and we're going to add it to 40 degrees, right? Right?
Yeah.
Yeah.
Okay? So, how are we going to figure out this angle?
Law.
You can do side, the law of sines.
Or law of
I
sines.
mean, law of cosines with side.
We could do law of cosines with side, side, side,
Or law of sines.
or law of sines,
But
okay?
you have to use the 5.63.
Yes, if we use the law of sines, either way, we're going to have to use the 5.63, okay? Now, the law of sines, this would be our biggest angle. However, this is something where, as you guys get more familiar with this, This has the potential to be an ambiguous case because we're finding the biggest angle. However, logically thinking here, all three of these sides are pretty close to each other, right? So if they're all pretty close to each other, all of our angles are going to be pretty close to 60, right?
Yeah.
You know, because if they were all exactly the same, it would be 60, 60, 60. If you see all the sides are pretty close to each other, you can be confident that this is not going to be obtuse. All right, so using the law of sines here would be okay. If this were like a 10, well, it couldn't be 10. If it were like 9 or something, you know, significantly bigger than the other two, then maybe you'd have to be careful and you might want to use the law of cosines instead. But we'll use the law of sines here. Sine of theta over 6 would equal the sine of 65 over the 5.63 that we just found. Okay? So then what do you get for theta?
73.55.
What?
Is that right? Anyone else get that?
I got 74. I don't know.
Did you use 5.63 or did you use the full answer or that
I
before you
used
rounded it?
5.63. Yeah.
74.99?
Well, I'm looking at it
It's 2 to 1
now.
right now.
I'm not getting that.
74.99? Okay.
74.
Alright. So,
How do I get this?
what direction did Esco hike? What was his bearing?
114.99 degrees.
Yeah. Okay. Because we had to add theta to the 40 to get the bearing. Did you figure it out?
Probably because you're around 8:30.
Yeah.
But
Me?
stuff close, you're probably around.
Were you getting that?
Yeah, I'm fine.
Oh, okay. Oh, you hit 5.67 instead of 5.63.
That would be a
Oh my
problem.
God.
That would be
That's
a
all
big
right.
problem.
Hey, that's why we all do it, so we can help each other and catch things, okay?
Dude, I like 0 and 10.
It drives me nuts when we're doing a problem like this, and only one person's on their calculator, and they do something like that, which happens, alright? But nobody else catches it until we're like at the very end, and then the entire thing is wrong, okay? So I'd rather catch it now. Alright, so we've got that. Now, here's kind of an interesting, you got it? Alright. Here's kind of an interesting thing here. I'm going to skip C for right now, since we're on the topic of the angles. All right. On what bearing should the hikers walk from the campsite to return
Oh, that's easy.
to P?
You just do 180 minus 74.99 minus 65.
No, because
Wait,
you
what?
need it. Then, because you need the whole thing
No,
from north.
yeah.
You don't just go from south.
We need this angle, right?
Oh, shoot. What do you do?
So the one in the triangle is 40.01.
Oh, you got 40.01?
So the one. Oh no. Never mind.
It's the one inside the triangle.
Never mind.
Yeah, what thing?
And then
Okay.
you just subtract that. Oh wait, no.
And but what's this little piece up here?
25.
That's 25, yeah, because that's the same as this right up here, right?
Yeah.
You okay?
Oh.
Stupid geometry.
No, you know that thing right there, the little bone?
Oh.
I'll probably do it.
Okay. So what's this angle here then?
294.99.
294.99? Okay. Good. Okay, so that's one way you can do it. Find the angle in here, find this piece, subtract those from 360, and you get 294.99. The other way you could do it is think about this. If I want to go exactly the opposite direction, what angle would I turn from where I'm aiming.
180 degrees.
180 degrees, right?
Oh my god.
So I was going 114.99. If I add another 180 degrees to that, that'll take me back where I started from. So here's the 114.99 plus 180, 294.99.
Whoa.
Okay? There's more than one way to do it. All right? However it makes sense to you, go for it. Okay? Now, C is kind of an interesting one, but this kind of shows you how we can now use the stuff we've been doing with the law of sines and law of cosines to figure out other things. Okay? So, for example, here, who's going to arrive first? Ritva must have been taking kind of an easier path. That's why they decided to go out of the way. So they were able to hike faster because the terrain must have been easier. Okay? Esko took the hard route, so he was traveling a shorter distance, almost half the distance, but he was only able to go 6 kilometers per hour. Okay? So let's think about this. How long does it take Ritva to go the full 10 kilometers?
An hour or each.
Oh, yeah,
1 hour, okay? If he's going 10 kilometers an hour, okay, it takes him an hour. What?
What's the h to the negative 1 thing?
Well,
Per
that's
hour.
divided by kilometers per hour.
Oh.
Wait a minute. It seems as if Esco gets there first.
Okay? Esko's going 5.63 kilometers at a rate of 6 kilometers per hour, so the time is distance divided by rate, right?
So 56 minutes.
So, what is that?
56 minutes.
Oh, if you convert it to,
Yeah, 56. I'm guessing.
if you'll get a decimal part of an hour, and then if you multiply that by 60, you got about 56 minutes.
So Esco got there
Don't
first.
you got exactly 56.3?
Yeah.
Right? Because you just.
Well, no, he's not. He's only going 6 kilometers per hour, not 10.
Yeah, but you got 5.63.
So if you move it over, it'd be 60.
Does it come out?
Oh yeah, because you
Yeah,
multiply
yeah,
by
yeah.
10.
If you think about it, if you move the decimal over, on the top, 56.3, and on the bottom, be 60. That's going to be minutes to around an hour.
Oh, look at 56.3 minutes.
Yeah.
Okay, yeah. That's good. 56.3 minutes. Okay. Good. All right. So who gets there first?
Esco.
Esco. All right. Shortest distance is a straight line. It's not always the easiest, but a lot of times it's still faster. How long will Esco have to wait before Ritva arrives?
3.7 minutes.
Yeah, 3.7 minutes. Okay? So, kind of an interesting question there. All right? Any problems, questions, anything about this one? Make sense?
We didn't put the answer for A.
Yeah, we did. That was X. That was 5.63.
Now we have an answer for A.
All right.
What's happening?